transformations. I've shown you all the different transformations. Now today is about what if there's more than one? How do I sort out what order to do them in? It's actually, there's some very specific rules that'll be fairly easy to follow. So, plan of attack. When performing a combination of transformations, it's easiest best. It also is easiest. The note's not incorrect. It is easiest, but it's best to execute the transformations in the following order. Stretches and compressions, do those first. Then do any reflections you got. Then any translations you got. Because there's only 3 types. I know there was horizontal and vertical of each one, but there's only 3 types of transformations. Now, notice we perform the ones that are multiply before the additive ones. That's not a new rule. That's BEDMAS. BEDMAS says if you're going to multiply or divide, do that before addition and subtraction. So that's the only reason this rule exists. This isn't me like giving you a management techniques. I'm just following math rules. Multiply first, then add or subtract. That's it. Do it. Here, jump right in. Go. Let's do it. Now, some people will like just working on the graph. Other people will be happier working on the table of values. So I will do both at once. Don't decide too early. Don't give up on table of values too early, because it could be you think you're a graphical person, but once you see the table of values in action, you'll be like, oh, I like that. Or maybe you think, I'm not really a graphical person, but once you see the table of values, you're like, ah, that's messy, maybe I like the graph. So I'll do both at once. Yeah? What's the base function here?
Oh, x squared. Y equals x squared.
Yeah, that hopefully in this course will not be too hard. There's only 4 you got to worry about. If there's a squared somewhere, it's x squared. If there's a square root somewhere, it's square root. If the x is in the denominator, it's 1 over x. So that decision hopefully won't be what causes you trouble. Then I say write down the transformations. That's how to start these questions. Oh, and I already gave something away. Oh, let me block it here. How many transformations do you see? 3. Yeah, 3. That's an important decision. Let's write them down in the order I said. Let's write down the ones that are multiply first, then the addition and subtraction ones, because that's the order I want you to do it. If you're like, no, that's too hard for me, then just write from the bottom up if that's what you're going to do. Kyle.
Vertical stretch.
Vertical.
Stretch. Oh, wait, compression because it's on the outside or whatever. So
No, it's on the outside. It's on the outside. You're totally right. So it's vertical.
yeah.
But does 1/2 make things smaller or does it make it bigger? Bigger. Smaller, so it's a compression.
Oh, okay, but then we used to then we flip them.
Yeah, good.
Wait,
Just a
so
second.
is it still going to be 2?
Hang on. Vertical compression, factor 1/2.
Whoa.
Yeah, no. Listen to the problem he's having. And it's actually good he's having that problem. We just need one little tweak. Who's got the little tweak in his thinking? Just to go, oh, like this.
Side.
Nope. It's 2 over 1, right?
This one's 1/2. No, this is right. What I've wrote is right. Hang on. Just wait for the tweak. As soon as you hear the tweak, you're going to be like, oh, right. Ben, you have the tweak? The vertical ones do what you think they're going to do. 1/2 stays 1/2. See? And it's not that weird. Like you're learning to juggle, and the first time you actually learn to juggle, it's like, whoops, well, oh, can't do it. Yeah? The vertical ones do what you think they're going to do.
But a horizontal one will be on the inside.
Horizontal one will be on the inside. See?
That's when
Now he's starting to juggle. He's starting to go, okay. So then it doesn't matter which one of these. They're both add and subtract, so it doesn't matter which one I do first. What does the +4 do? Left 4. Yeah? Because the inside ones do the opposite of what we think they're going to do. So this is a horizontal translation. And when you're writing this note, if you're starting to do short forms, I'm okay with that. I love the short forms. But I'm not going to do it. Because I'm teaching. Horizontal translation left 4. And then there's finally one last one.
It's just down 5.
It's just down 5. Most people think that outside one sticking out there is the easiest one. I'll write the fancy words. Vertical translation. And I wrote them in the order that I'm going to do them. I wrote things that are multiply first, and I wrote the ones that are add or subtract second. You don't have to write them in that order, but you have to do them in that order. Adele? No, no, no. You'll probably feel rushed in the test. You'll be scrambling along. I know what VC is. I know what HT is. You know. No, no. Yeah, short forms are totally fine. Yeah. Okay. Table of values people then. Here's what you'll do. Table of values people will go, okay, let me make a table of values for the base function. And for most base functions, actually, -3 to 3 is the ones that you'll use. We've found out with square root, those aren't the best choices. But here they go. -3, -2, -1, 0, 1, 2, 3. Square them all. Graph people might just go right to the graph. They're like, I can build x squared without your silly table of values. Table of values people are like, hold on. There might be more to this than meets the eye. Don't give up on table of values yet. So I want you to see both at once. But if you're graphing, you'll be over here going 0, 1, 4, 9. Same exact information. Now, I'll do all table of values for a while, and then I'll come back and do the graphing version of it, okay? Hopefully tying them together nicely. Here's what table of values people will do. They'll go to their table of values, and they'll go vertical compression factor half. They'll write up here, vertical compression factor a half. If I'm going to do a vertical compression factor a half, then this table of values is not correct. I've got to take all the y values and multiply them by a half, or I could just divide by 2, all right? So either way, whether I'm multiplying by half or dividing by 2, here's my new y values. Here's the ones I should do. 4.5, 2, 0.5, 0, 0.5, 2, and 4.5. Don't let me away with something here. If you have a question about what I just did there, it's the key question. The order of doing things and the table of values, that's all going to be pretty easy, actually. We're just graphing points. But what I did there, if that's mysterious, you need to tell me now, because that's the tough part here. Do you have questions on those numbers? I multiplied them by a half, or I divided them by 2, however you want to think about that. Next table of values, people. Then you'll go horizontal translation left 4. Will that be on the x's or the y's? The x's. So over here, you just write up here something that you understand, and hopefully enough that I understand. I go, oh, I see what you did there. Left 4. So just a little bit of information here. If I go left 4, what happens to the x values? Subtract 4. Yeah? So this is now -7. This is -6, -5. Don't be annoyed with the active board. It's not its fault. And if it's mysterious why I'm changing all these values, it's because these aren't the right x values for the transform function. I need to take all those x values and move them left 4. These are the right x values for the transformed function. I got one more thing to do. What's the last thing? Down 5. Do you see why I wrote them out beforehand? I think you're going to find it easier if you write them out beforehand so you know all what you have to do. So then the last thing is down 5. Down 5 means subtract 5 from all these. So this is now -0.5, -3, -4.5, -5, -4.5, -3, -0.5. Maybe you need your calculator. That's fine. I've done a million of them, so I can do those subtract 5s in my head. So after I'm done all that table of values, people, now I've got the correct x values for my function along with the correct y values for my function. If you're right with me, you're like, oh, I'm done. Now I just graph those points, and I've got my new transform function. Now's the tough part of the lesson. If you understand that, you're home. But here's the way I'm teaching this is a little tough because you have to watch what I'm about to do. Now I'm talking to graphing people. Here's what graphing people will do. They'll grab this point, and they'll just look at the transformations. And they'll go, okay, vertical compression by factor of half, stays where it is. Left 4, down 5, there's a point on my new function. See, they'll be a little faster. They got to use a little more brain power, but they'll be a little faster because they just moved it over. You know, there's a point at negative 4 or 5, negative 5, and the table of values people go, yeah, I see it, negative 4, negative 5. I would have got the same thing. This is the way I was taught, so I'm sort of addicted to it. I'm into it. I like how to do this, but I understand the table of values too. It's really powerful. So take this point, vertically compressed by factor of half, so it goes down to a half. Then move left 4, 1, 2, 3, 4. Then down 5, 1, 2, 3, 4, 5. You got a point negative 3, negative 4.5. The table of values people are like, yeah, I got it. Which one's faster? I think the graphing's faster.
Wait.
But if you're confused over here, this is way better. There's a lot less confusion going on over here. You got to know what you're doing when you go over here. Kyle.
Can't we just so when it like the 0, like the middle point in the graph, if you just like go like horizontal, like so like x if you go negative 4 and then y you go.
Hold your question until I finish the red graph. Okay. Let me finish the red graph because he's asking a great question about grade 10 math. Okay? So and I've got the perfect answer for it. I know just what to say, but I need the whole red graph first before I do it, okay? So then this one, this point at 2, 4. Vertical compression factor of half, so I divide the y value by 2. I go left 4, 1, 2, 3, 4, and then I go down 5. 1, 2, 3, 4, 5, and I get this point, negative 2, negative 3. Aren't I proud? And the table of values, people are like, yeah, negative 2, negative 3. No problem. Don't give up on either method yet. There are times when this method's better. There's times when this method's better. If it's a lot of transformations and you're a little distracted, I think you'll find table of values. This one takes a little more focus. That's what it really takes. So 9 divided by 2 is 4.5. Left 4, 1, 2, 3, 4. Down 5, 1, 2, 3, 4, 5. Negative 1, negative 0.5. Same point. So again, if you're watching this going, can't I just use the table of values? The answer is yes, absolutely. Go ahead. I'm just trying to show what's actually happening with the graph. Let's do this one. It gets faster. I get faster as I do the points because I start to memorize. I don't have to look anymore. I know what I got to do. Vertically compressed factor half, left 4, 1, 2, 3, 4, down 5, 1, 2, 3, 4, 5, boop. Yeah. It's fun. It's more fun. This is more fun. It's got to be. The graphing is more fun. Vertical compressed factor half down to 2, left 4, 1, 2, 3, 4, down 5, 1, 2, 3, 4, 5. Am I saying it fast to show off or to get the lesson done quick? No. I'm trying to show that the method can be very fast here. It's not big lines of tables and punching numbers in my calculator. You just zip right along here. Last one, 9. Vertical compression factor half to 4.5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Boom, bah. There we go. I'm going to draw a curve through those, okay? Okay, technically speaking, I see that I could get more points here. Maybe I should go get more points. But I'm not going to hold you to it in grade 11. If you transform the points you got there, show me those, I'll be happy, okay? We'll just take it at that. But can you see that really I probably could get a couple more points? I could probably add 2 more points to my original table of values, transform those, and get the complete graph. I could do that. Kyle, we're ready for your question now.
Oh, why can't you just like move the 0 point to the? It basically gives you, where to put it.
Grade 10 math. Grade 10 math. This is a parabola. Its vertex is at negative 4, negative 5. My graphing rule is 1/2, 3/2, 5/2. Can't we just use that? The answer is yes. The answer is yes. However, that method doesn't work if you do the root function or the 1 over x function or later in this semester, sine x, cos x. So we're developing a method that will work for all functions, not just x squared, and we're using it to practice on ones we've already seen.
So that won't work for...
That basic method you're talking about won't work necessarily on other functions.
It only... Okay.
Yeah? So could you do this question? If this was on the quiz or test, could you go, oh, I'll just do this like in grade 10? He'll have no idea. No, I won't have any idea. You're right. You could do this question using grade 10 methods. John.
So like, can't you just like apply like the current distance to like the horizontal one and like the vertical one, and then like just like use the a value of 1 over 2?
Absolutely. Because it's an x squared, a parabola that we know so well, we learned in grade 10 that for a parabola, we could just over there and then just use the graphing rule. Okay? So I'm doing it a different way to get ready for 1 over x, root x, later in this course, sine x, cos x. There's lots of other functions coming. So I'm more generalizing the method here and not assuming any knowledge. But you're right. Hopefully when this is over, you're like, you're just doing parabolas. You're just thinking of it a different way. And that's true. It's a math teacher trick. Math teachers for thousands of years have taken a question, done it a different way, and used that new way to do tougher questions. Yeah, good. Good questions. Other questions there?
Oh, the domain range. It wasn't.
Oh, good. I missed that. I didn't notice that. Domain.
It's just.
X element of reals. All parabolas. X element of reals. Range, though,
It's greater than or equal to
greater than or equal to
-5, right?
-5. Good.
Wait, so do we have to write the 1?
This is not a 1.
Is it?
That's a
The
line.
line.
That line in fancy mathematical terms means such that. So use any y value you want, such that the y's are greater than -5. Most grade 11s think of that line as meaning, but, hang on. Y element is, but the y's have to be greater than -5. Whereas the x values, there's no restriction. You can use any x values you want.
You use any x value?
Yeah. I can just, this parabola just
So
keeps
when it
going up
says
forever.
state its domain and range, that's what it wants you to do?
That's right.
Oh, okay.
Good. Other questions?
What if it was like, wait, never mind.
You okay? Good stuff. More time? All right. Example, the graph of y equals root x is vertically stretched by factor 5, reflected in the x-axis, and translated 7 units to the right and 4 units downward. Write the equation of the transform function and state its domain and range without graphing it. Here's how I do these. I write y equals square root, I don't even write the x yet. And I just go through them and fill in the numbers and where they go. For instance, vertically stretched by factor 5. Where does the 5 go?
Out front.
Out front. Vertical stretches go out front and they stay the same. Vertical does what we think it should. Vertical behaves nicely. Multiply by 5 makes things 5 times bigger. Reflected in the x-axis. Where does it go and what do I put on this to reflect in the x-axis? Hold on. Just give everyone a couple thinking moments here. If it's reflected in the x-axis, see, this tries to fool you. It's like reflected in the x-axis. Where's the x-axis?
I know where.
So what kind of reflection is it?
Oh, I know. Mr. Star, I know. Excuse me. Excuse me.
I know you know. I think it's possible that someday you'll be a teacher.
That's not happening. Never.
If there's anybody else in the teacher in the room, do you see what I'm doing? I'm waiting. The awkward pause to let everybody go, wait a minute, wait a minute. You're thinking about dinner or you're trying to think about, is a hot dog really a sandwich? And you're trying to go, okay, what did he say? He obviously thinks this is important.
I know this one.
Let me just look at this for a minute and I'll think about it so I know if I know the answer or if I don't know the answer. Either one is good. Really. If you got the wrong way around, you got to find out it's the wrong way
I
around.
know this one.
Cal, do you know the answer?
Yeah. It's a horizontal, so it's like because like x is horizontal or whatever, and then like a reflection. So would it be like inside the brackets?
No.
Oh no, not inside. My bad. It's after the 5 to make the square root negative, or no, not to make.
Oh,
Like-
that's technically right. Technically, I could go 5 times negative root, but we don't. We usually put it right out here. But I could put it there.
Wait, why we? No, because I was gonna say that, but then you were saying, oh, like this one tries to trick you. I thought that was for like vertical because.
The reason I said it tried to trick you is when it said x I think it's automatic to go put the negative with the x. Yeah? But you got to think, go, it's reflected in the x-axis. It's the y's that are reflecting, which means it's a vertical reflection, and the negative goes out front. Yeah?
Because I saw that it said like it's vertically stretched, but then it kind of like messed me up when it said like.
I know. He's
reflected.
running into exactly the juggling problems, right? To balance all this stuff.
Because that's horizontal, right? X is like the horizontal line.
So what's that one? Translated 7 units to the right.
X. No, 7.
7 to the right.
Minus 7.
Minus 7.
Minus 7.
4 units downwards.
Plus 4. Oh, no, minus 4.
Good. That's exactly the thinking that has to happen. You go plus 4, no, wait, minus 4, and it goes outside the brackets. Now, to state the domain and range
I know this one.
without the graph,
So
I don't know. I don't know.
it gives you numbers.
He says it gives you the number. So, if he gets it, we'll have this much respect for doing it without the graph. We'll go, okay, I guess it's possible. Most of you have to get at least a sketch. You don't need a perfect graph, but you need at least a sketch of this graph in your mind to be able to do it. He's going to do it off the numbers, he claims. Let me get him set up here. I'll write down what he says in blue, just in case it's not right. And then we'll check it by sketching a graph. What do you like here?
I'm getting confused, but okay. X element, like realm or whatever, and then
X element of the realm. That's good, actually. X element of the realm. Any X you want. Good. Such that.
I don't really know what that means, but then I know
Such that.
Such
Yeah.
that X, greater, like X greater thingy, and then you gotta put like the symbol. No, there's no symbol there, is there?
No,
Is there? Okay, then you just do
What number? Tell me the number.
7, -7.
Folks, he's right.
Oh no, it's 7 because it's negative
Yeah.
to the positive in
Yeah.
real life. But the other one will.
There's no way he's getting this one. There's no way he's getting this one.
No, Mr. Todd, I guarantee it. It's
Guarantee.
Y element of.
If you get it right, you can use a pen the rest of the semester.
I.
If you're wrong, you switch to pencil right now. Hold on. Oh, I'm a betting man. Here we go. Oh, no. I don't even care about that. Purple. 0.7 millimeters. It's good, man. You try it out. If you haven't tried a 0.7 millimeter pencil. That's good. I know. You're right. You don't.
No.
Tell me. Why element of real? You're not making the bet?
Why? No, I'm not. I'm good.
Make the bet.
Oh, he's too scared.
Make the bet.
Okay.
Don't be a bum. Don't be a bum.
No, I won't.
No, he's not being a bum. He's being a chicken.
Like Y, and then the symbol thingy, greater than or whatever.
Which one?
Greater than.
Greater than? Okay.
4. No, -4. -4. My
Negative
bad.
4.
My bad.
Does he have it right?
No way.
Does he have it right?
That's not true. No, this is a lie.
I'll just put this here.
What do you mean? That doesn't make sense though.
I know. And it's a fair warning, I'm telling you, that the graph might be.
Wait, Mr. Todd, it's 20.
There's no 20.
Oh wait, it's infinite. It's infinite.
You lost your pen rights, man.
Yes.
It's either infinite. No, it's either infinite or 20.
Hold on. Give me a chance here. Okay? Do we agree this is root x? That's the base function. And it's been moved right 7 and down 4, making you for a second think that Kyle's going to be using a pen the rest of the semester, right? Because right 7 down 4. And notice I'm not doing a perfect graph here. You don't need a perfect graph. You just got to go, okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So it's over here somewhere. Yeah? Right 7, down 4. Things are good. Kyle's right. Greater than or equal to -7, greater than or equal to -4. Except for one thing.
Yeah. Oh, is it because it's reflected that it like you go in like back down? It's reflected. I knew it before you. Yeah, I knew it. I'm a genius. So that means that it's. Yeah. Okay. So it's 0. What?
nice one, Kyle.
What? Wait, no.
Pencil, buddy.
Mr. No, because that doesn't make sense. Because is that the right answer?
This reminds me of the conversations I have with my son Bennett. They're a lot like this.
No, that's what I said.
You did not say that. I asked you. I paused. I went, let's just wait. Let's get him say it. And you said greater than.
Yeah, 'cause that's greater than.
That's less than.
No, because I know that. Because I know that the small number eats the big number. No, wait. No, the small number eats the big number, right?
The smaller number is the bigger number? You might want to work on that sentence a
Wait,
little bit.
y is greater than. No, because the smaller number eats the bigger number.
You just said the same thing again. Hold on. I'll call it a tie.
Wait, so.
And we'll finish the lesson.
That's 8.
This is the same question, just phrased a little bit differently. But if you've fallen asleep or got distracted by me entertaining myself talking to Kyle here, you got to watch out for this one. This is the number one problem in this chapter right here. Somewhere along the way, you have to get used to the idea that this is not set up to read the transformations off. And I put a little box here to identify the horizontal transformations more easily. I don't know what I was thinking when I typed that. No, change it right now. Change your note, not more easily. Accurately. And I spelled accurately wrong, which is hilarious in all sorts of ways. Accurately, you need to factor the coefficient of the x term. This is very strange why this has to be this way, but I'll circle back at the end and explain why it has to be like that. You need to take the horizontal reflection out of the situation to see the proper horizontal translation. Whoa, what a sentence that is. What I mean by that is it needs to look like that to be able to get the proper transformations. You need to take the negative out front and go, no, get the horizontal transformation out of this first, then I can see the right-left transformation properly. That will happen again and again, and me, your functions teacher, will make sure it's on the quiz. I'll make sure it's on the test on at least one question. Your advanced functions teacher will put it on there because it just keeps coming up again and again. When you get something like this, it's not ready. The negative has to be pulled off, or the 2, or the 4, or whatever it is. You've got to get the stretches out of there so you can see the proper horizontal transformation. So, now I'm ready to list the transformations. How many is there? Oh, I gave it away last time, didn't I? How many is there?
Oh, I know. Damn. I feel like there's 4. I feel like there might be.
There's 4. 1, 2, 3, 4. But let's try and list them. The multiply ones first, the add or subtract afterwards. What's this one? Anyone but Kyle? Yeah.
Doesn't f of x equals root x? Where's the root?
Oh, good. I'll get to that. Wait. Right now, I'm just going, whatever function we're talking about, let me talk about what 4 transformations I have to do. And then I'll bring the root x back into it in just a second. So, this 2 out front, what does it do? Vertical stretch. Factor. Two. The vertical ones do what they say they're doing. You don't have to do anything with those ones. When it's horizontal, you got to be careful. Next. This negative in here. This is what your brain's doing. Ben? Yes, I'll write extra words just in case you're using different words. Horizontal reflection in the y-axis.
Why is not horizontal?
It is a horizontal reflection.
Yeah, no, it is a horizontal reflection, but like y, I know that y is like this, x is like this.
There's y.
Yeah.
That's the mirror. That's what we're reflecting over. So think of the reflection in the y-axis. That's what we're using as the mirror, the flipper. Yeah?
Yeah, but wouldn't that be vertical because it's up? It's an upwards mirror.
That is a vertical mirror doing horizontal
Oh, it's 'cause it's
reflections.
flipping from the right side to the left side.
Good.
not up,
Absolutely.
down.
Absolutely. The +3 in the brackets. Horizontal translation. Left 3. And then the +4 vertical translation. Up 4. I hope those two are starting to become easier. It's like, okay, I'm good with the translations. The reflections and the stretches I'm still working on a little bit. So to actually do this, I need to build a base table of values if I'm a table of values person. I'm going to try and do both at once and convince you could do it with right on the graph. Table of values person needs to know what function are we talking about. This question does give you which function we're talking about. It's the root x function. And hopefully you're at the point where it's like, I know which ones to use here. Those are the points to use. A graphing person would be like, I don't need a table of values to build the function. It's the square root function. I know that one. 0, 0, 1, 1, 4, 2, 9, 3. And I agree with them. I agree with both of you. I like the table of values. I like the graphing. I like both ways. There it is. And then just do the 4 transformations. It can go pretty fast, actually. To do vertical stretch times 2, you're just multiplying all these by 2. 0, 2, 4, 6, 8. Yeah. The table can go pretty fast if you know what you're doing. If you're doing vertical stretch by factor 2, just multiply them all by 2. I don't think I did a perfect job of lining them up last time, so I'm just going to be a little more careful. I'm not changing the numbers here. I'm just going to be a little more careful about lining these up because I'm not on lined paper like you are. So I got to be a little more careful. It's probably going well for you. Oh no, you're in blank spaces too, right? So just be a little careful to keep them lined up. Horizontal reflection in the y-axis. If I'm reflecting in the y-axis, which values am I reversing the sign on? The x's. So here, over here is the horizontal reflection. 0, -1, -4, -9, -16. Left 3, that goes over here on the x's. Left 3. If I'm going left 3, what happens to the x values? I'm subtracting 3, right? So I go -3, -4, -7, -12, and -19. I did that really fast. Did I make a mistake? No, it looks right. And then up 4 is back over here. Move these all up 4, 4, 6, 8, 10, and 12. And if you're right with me, you're like, oh, I like this. It gives me the numbers. There's the new points. And I'm going to put a box around them saying, these are where the x values end up. This is where the y values end up after doing those transformations. Now, go back to graphing people. Graphing people go, can I do this without all the table of value stuff? And the answer is yes. You start at 0, 0, and you go, okay, what do I got to do here? Vertical stretch factor 2, that doesn't move it. Horizontal reflection of the y-axis, that doesn't move it. Then I go left 3 and up 4, and I get the point -3, +4, which is the first point on the table. So both people are going to get the same answers. It's just how you want to get there.
Wait, but where's the vertical stretch? Like,
Yeah, you won't see it yet on that point.
No.
Yeah, hold on. Let me get the other points on, and then you'll see it. 1, 1. Vertical stretch factor 2, so that goes up to 2. Horizontal reflection of the y-axis, that flips over to this side. Left 3, 1, 2, 3. Up 4, 1, 2, 3, 4. There it is. And graphing people have to have a little more faith in the process, because after the first couple of points, they might be like, I don't know if it looks right or not. Just keep going. Once you get other points on there, you'll see everything in action. But again, go ahead, use the table of values. I have no issue with the table of values. I'm just saying there's another way to do it. Okay, this point, 4, 2. Vertical stretch factor 2, so it goes up to 4. Horizontal reflection in the y-axis, so it goes over to -4. Left 3, 1, 2, 3. Up 4, 1, 2, 3, 4. Usually it's the third point that makes you feel better. Like, there it is. It's been moved over there. It's vertically stretched, but it's now going this way because it got horizontally reflected. Does the next point even fit on?
No.
Negative 12, negative 10. So when that happens, you're like, okay, that's no problem. It just means I go like this, and I'm just pointing an arrow. The arrow's not going on there. An arrow there saying that way. Maybe I can just scroll up a little bit and get the arrow on there. Okay. Is that easy? I don't know. Sort of takes practice. You got to do a few of them till you get this down pat. But who's your best friend in all this? When you're working on the graph and things aren't working out, Desmos is there. You could plug this thing into Desmos, and you can see, oh, it goes there. I just missed one point. It's usually one point. You're like, oh, that point doesn't go there. It goes there. Oh, now it looks right.
Wait, but where's the factor? Like, where's the two vertical stretch going?
Right here. See? To get to the first point here, sorry, the second point, it goes over 1, up 1. Here it goes over 1, up 2. That's the vertical stretch part of it.
Over 1, up. So you just times it by 2?
Yeah.
So we already did that. We already did that when we and then up.
Yeah, the table of values takes care of all that for you.
What if we just do like what if we just find any point on the like 1, like for example like 1 and 1 for the like normal one, you just re-reflect it to negative 1 and 1, and then
That's exactly what I did. I stood right up here and I went whoop, 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 and moved it up.
so you don't even really need to write all of it out. You just,
No, you have your choice of which way you want to do it.
because it tells you the steps if you write it all out. Like
Yeah.
the 4 points.
Yeah, good.
Okay. That was a domain.
Does it say do domain range?
Yeah, I think so. Oh, state the domain.
Yeah, okay, so domain, x element of reals, such that x is less than or equal to negative 3, and range y element of reals, such that y is greater than or equal to 4. Easy to get wrong when there's reflections. Be extra careful when there's reflections because you can get them exactly wrong. So if you get an answer that's exactly the opposite of what the back of the pages say, it's probably because you missed the reflection, because it completely reverses domains and range when you do those reflections.
Don't we wouldn't it be, because if it says like to the left 3,
Yep.
wouldn't that just be a positive 3 because it changes back? Or
No.
no?
The positive 3, we reversed it when we made it left 3. So we are that's already reversed. So we don't reverse it again. No.
Okay.
That's a good question.
So it's already.
Other questions?
Oh, because on the actual graphic, the actual question it says no.
Yeah. Other questions? Yeah. Where's the root? I use that in my table of values. Oh, yeah, sorry, I got to scroll up. They said if f at x equals root x. So eventually I did use that information. Because without that information, I wouldn't be able to draw the graph because I wouldn't know what the base function is. And this one says, let's talk about functions and the transformations. And then when I'm ready, I go, what function are we talking about? Root x. Okay, good. Other questions? More time there? Is there one more? All right. I put one more of these in here. There's not many examples here because we don't need a whole lot, but we do have to recognize that there's a problem with this particular function before I even start. I'm going to write it over here. And this is the one that's going to get you. And I'm telling you, I'm going to do you a favor, and I'm going to put one of these on the quiz. There's going to be one on the test, at least one, where you have to go, what's the problem here? There's a major league problem with the way this is written.
Oh, I know this one.
Does he?
I know.
I'm going to ask you. I'm going to ask you. You can be patient because I'm going to ask you, Kyle. I want to give everyone time to look at that to understand what the difficulty is when they write it like that. And it's not just to torture you, by the way. As we go along, it's just going to happen. Where all of a sudden, common factor first. It's under PLO. It's going to be up there come quiz time. So on the quiz, as you're walking up to hand your quiz, you look in there. You look in there. Did I find it? It's there somewhere. He put one in there that you got a common factor first. And so this is 2x minus 5. If you've understood the rest of the lesson, then what I'm going to do next is completely boring. I'm not going to do anything different than what I've already been doing.
Oh, it's inside the bracket, so it doesn't affect.
Question.
Is there ever gonna be like, say like it's 2x minus like -7 or something like?
Could decimals and fractions rear their head here? Yes. Yes, it's possible that I factor out the 2, and this doesn't divide by 2. I'm going to have to force that factor out. Because up till now we've said, oh, well, don't factor it then. You're right. We're going to have to factor that 2 out no matter what this number is. When I wrote this up, I made it a 10 to go, let's do something nice to start off with. But you're right. If that's an 11, it's going to be 2 bracket x minus 5.5, and I'm going to have to live with it. Yeah? Okay. All right. How many transformations? 4. Oops. Who's so good at these already? Is there a juggler out there that can, Hazel believes she can just list them? Go, Hazel. I like that she's included the other words. Vertical reflection in x-axis. Keep going. Give me the last 2 first. Think about that one first. Give me the last 2. Horizontal translation, right 5. Vertical translation, up 6. And I'm going to try to cleverly ask you 2 questions, make you explain your right answers here. Vertical translation up 6, and hopefully lead you to changing your other answer a little bit. You ready? Vertical translation up 6. How did the positive 6 tell you that that was up 6? It's easy, right? Outside the brackets, vertical does exactly what you expect it to do. She's already got it, right? Now, right 5. Well, that's a negative 5. What are you talking about, Hazel? How can it be right 5 when it's minus 5? In the bracket, the horizontal ones go against our intuition. Now give me this thing, this 2 inside. Tell me about it. Yes? Compression, good for you. Factor 2. I won't mark it wrong if you write factor 2. Because I know what you mean. And some people would argue, it's compression factor 2. I just said it was compression.
Why would you 1 over 2 though?
Yeah, but technically we usually write 1/2. But I understand when people write it. I'm not going to circle it, mark it, put a red thing to it. I'll be like, as long as you do it right, I know what you mean. Yeah? But technically in the math language, we call it factor 1/2. That's the hardest part. I think that's the hardest part. Table of values for y equals x squared. Here it comes. I'm going to buy myself a little space here. You let me know if you need me to scroll back up, okay? Oh, it's this thing's the problem. I'll move it out of the way. Excuse me. Over there, please. There we go. Vertical reflection of the x-axis. Is that x values or y values? In your brain, you should be like, okay, vertical reflection of the x-axis, that's this way. That's the y values. So vertical reflection.
Really, Nate?
Sorry, am I interrupting your phone time with my lesson here?
I'm sorry, Mr. Todd. 100-yard kick
Reese, keep in line over there, will you please?
100-yard kick return on extreme. It's crazy.
Horizontal compression. Factor a half. Stay with me another couple of seconds. Factor a half. Going to multiply these things by a half. What's the other option? You might like dividing by 2 better. So this is negative 1.5, negative 1, negative 0.5. Yes, sorry, a little bit of decimal work here. Oops, I almost wrote 1/2 there. I'm okay with the decimals here. Right 5, that's over here. Right 5 would be adding 5 to these. Maybe you need your calculator. I don't know, I can do it in my head. And then finally up 6. And so what I've done on the table of values is I've taken the x values to their transformed location and the y values to the transformed location. So that's my correct table of values for this particular function. But as promised, I'm going to do it as a graph and just make sure it works out right. Graph people will go y equals x squared. I know what y equals x squared looks like. And then they're going to just use the list of transformations and do those to each point to see where they end up. I encourage you, with whichever method you choose, to do at least every 5th question the other way. To go, do I see what's going on here? Do I understand what's going on? Not that I'm setting you up to do one way or the other. I'm not. You can do it either way. I do not care one little bit. And the future courses don't care either. If you do advanced functions and you do these tables the whole time, you'll do fine in advanced functions. There's no problem with that. Let me try and do it. I'm going to take this 0, 0. See if I end up in the right spot. Vertical reflection the x-axis, that does nothing. Horizontal compression, that does nothing. Right 5, up 6, 2, 4, 6. There it is right there. I got 5, 6. Is that on my table? Yes, the table of values people would get that point. No problem. Let me do it with 1, 1. Horizontal compression factor half, so it's down to 1/2. Vertical reflection the x-axis, that's down to here. Right 5, 1, 2, 3, 4, 5, up 6, 1, 2, 3, 4, 5, 6, right there. 5.5, 5. Yes. Okay? So it works either way. If one way or the other is bothering you, you can rely on the other way. Next, this point, 2, 4. Vertical reflection in the x-axis, that goes down to, oops, I'm leaving a trail of ink there on my diagram, down to 2, -4. There. Horizontal compression factor a half, here. Right 5, 1, 2, 3, 4, 5, up 6, 2, 3, 4, 5, 6. 6, 2, yes. Yeah, same either way. And after that, I would get 6.5, -3, just like I do off the table. And I'd get 4.5, 5. And I would get 4, 2. And I would get 3, -3. And if you remember your grade 10 stuff, you have an advantage here because you know how it's going to turn out anyways. Domain, x element reals, all parabolas have that. And range y element of reals such that y is less than or equal to 6. What questions do you have? I really get this stuff. I understand it. I think I'll skip tonight's homework. Are you out of your mind? The stuff that you understand, that's the stuff to really kick it on. That's the stuff that like, oh, I think I can ace this quiz for real. Not because I understood the lessons. Watching me do it's no good. You wouldn't watch a basketball player shoot 20 baskets and go, I really get that. I could play in the NBA. No, no. Get the ball out, get the homework out, and you do it.
Mr. Todd,
Yeah.